Hello friends, welcome to the class on control engineering. So in this class we are going to solve another problem on root locus. Okay, so here they are given the g of s into h of s. There is a open loop transfer function is been given. So let us start doing the problem. What is step number one? To find out the number of poles. So here the denominator term, that is number of poles, is equal to 3. Okay, so number of zeros, that is the numerator term, that is s terms, that is equal to 0. Therefore number of branches will be equal to 3. Okay, so what are the starting points of the branches? So that are the roots of the poles. What are the roots of the poles? That is s is equal to 0. So now this is a complex pole. So how to find out the roots for this? I hope you know the formula. It is minus b plus or minus square root of b square minus 4ac divided by 2a. So we are going to apply this formula here and we are going to find out the roots of s. So after applying, so this roots are minus 1 plus I, next minus 1 minus I. So these are the two roots. Okay, next, so therefore these are the starting points of the branches. What are the ending point of the branches or terminating points? That is s is equal to, see, we don't have any zeros, hence all the branches are going to end at infinity, infinity and infinity. Okay, next step number 2. So we are going to plot pole 0 plot to predict the root locus on the real axis. So pole 0 plot. So we have to draw the pole 0 plot like this. So what are the roots? We have 0, then minus 1 plus I, next minus 1 minus I. Okay, so there are only one root is there on the root locus. So therefore root locus is possible on this real axis. Root locus is possible on this real axis. So therefore next step number 3, root locus is possible on the real axis. Step number 3, that is to find out the asymptotes. So therefore what is the number of asymptotes? Is equal to p minus z. So that is equal to 3 minus 0, that is equal to 3. Next, to find out the angle of asymptotes, we know that is q is equal to, theta is equal to 2q plus 1, 180 degree minus p minus z. So here q is going to vary because the number of asymptotes is 3. Q is going to vary from 0, 1 and 2. So if I substitute q is equal to 0, what is theta 0? So that is equal to 60 degree. If I substitute q is equal to 1, that is theta 1 is equal to 180 degree. Then q is equal to 2, theta 2 will be equal to 300 degree Celsius. 300 degree. Okay. So next step number 4. To find out centroid. Centroid is equal to summation of real part of poles minus summation of real part of zeros divided by p minus z. Okay, so after substituting summation of real part of poles, so we have 0, right? Then it will be minus 1 and minus 1. So we don't have any zeros. P minus z, that is equal to 3. Okay, so how much we got? So we got minus 2 by 3, that is equal to minus 0.66. So this is a centroid. Okay, so next one, step number 5. What is step number 5? To find out breakaway point. So this is step number 5. How to find out the breakaway point? We need to have a characteristic equation. What is characteristic equation? 1 plus g of s into h of s is equal to 0. So 1 plus k by s square plus 2s plus 2, that is equal to 0. Okay. Next, after simplification, so I got s to the power of 3 plus 2s square plus 2s plus k is equal to 0. So this is a characteristic equation. So therefore, what is k? K is equal to minus s cube minus 2s square minus 2s. So let me call this as equation number 1. So now what I am going to do, I am going to differentiate k with respect to s. Okay, so this can be minus 3s square minus 4s minus 2 is equal to 0. Okay, so now what we have to do, with the help of calci, we are going to find out the roots of the s. So after, with the help of calci, we found out that s is equal to minus 0.66 plus or minus I 0.471. So this is the roots of this equation. So now we need to check the validity of this breakaway points. See, with the help of this, we got the two roots, we got it. So usually what we have to do, we have to substitute this value in the equation number 1. If the k value is positive, then we consider as a valid breakaway point. But in this case, we are getting the complex roots, right? So this is very much important. When we get the complex roots, how to check the validity of the breakaway point is that, so we are going to apply the angle condition to check validity. So we are going to use the angle condition to check the validity, whether this is the valid breakaway point or not. Okay, so let us show the angle condition. Okay, angle condition. What is the angle condition? So angle condition says g of s into h of s at s must be plus or minus 2q plus 1 into 180 degree. So as we know, q is going to vary from 0, 1, 2, 3 like this. That means if I substitute 0 here, I am going to get 1 into 180. If I substitute 1 here, so I am going to get 3 into 180. That means odd multiples of 180 degree. Okay, so let me show you how to do it. So for this, so what is g of s into h of s at s? So here what is the value of s? Minus 0.66 plus I 0.47. I hope that is the root what we got. S is equal to minus 0.66 plus or minus I 0.47. So first I am going to consider minus 0.66 plus I 0.47. Okay, so what is g of s into h of s? We are going to apply the angle condition. We have k term divided by, we have s term. Okay, next we have a complex roots, right? So this is a complex roots. So therefore, how to write this one? Please pay attention over here. So this we have s, what I written. So s square plus 2s plus 2. The roots are minus 1 plus I, minus 1 minus I. How to write this one? So this will be s plus 1 minus I, then s plus 1 plus I. Okay, so I need to get the equation like this. See, pay attention on this. So here I got roots of s is equal to minus 1 plus I. So if I substitute, if I take to this to the left side, then it will be s plus 1 plus minus I. Okay, so this will be s plus 1 plus I. Okay, so here what I am going to do, I am going to substitute the values of s in this s. Wherever s is there, I am going to substitute this value and I am going to simplify. So this can be written as k plus I0. So there is no imaginary number. So divided by, what is s? So it is 0.66 plus I 0.47. Okay. Next here what is S? Minus 0.66 plus I 0.47 plus 1 minus I. Correct. Next, what is S? 0.66 plus I is 0.47 plus 1 plus I. Okay. So now after simplifying this, so what I am going to get is, so this is K, there is no changes here, I is 0. So this is same, minus 0.66 plus I 0.47. Next this will be 0.34, correct, 0.34 minus I 0.53. Next this will be 0.34 plus I 1.47. Okay, now I need to find out the angles for this. So I am going to apply tan inverse of y by x. What is y? So I know complex number is represented as x plus iy. So in the same way I need to find out the transfer function, tan inverse of y by x for each term. So here it will be, if I apply this here, so this will be 0 degree, correct. So minus, so after this, so this will be minus 35.45, and this will be minus 57.319. Next this will be 76.97 degree. So these are the angles I got. Now to simplify, so this is 0. If I take it to the numerator, this will be plus 35.45 degree. This will be plus 57.319. This will be minus 76.97. So if I simplify it, and the final answer I am going to get is 59.79. Whether this is the odd multiple of 180 degree? No, right? So this is not the odd multiple of 180 degree. Therefore, minus 0.66 plus I 0.47 is not a valid breakaway point. So this is not a valid breakaway point. If this is not a valid breakaway point, conjugate of this, that is 0.66 minus I 0.47 is also not a valid breakaway point. So this is how we are going to check the angle condition. So in this problem we don't have any breakaway points, right? Okay. So next thing, so step number 5 is over. So we came to conclusion that there is no valid breakaway point. Next, what is step number 6? To find the intersection of root locus with the imaginary axis. So to find intersection of root locus with the imaginary axis. For that we need a characteristic equation. What is the characteristic equation? S cube plus 2s square, that we already solved in the previous case. 2s plus k is equal to 0. So what we are going to do? We are going to draw the array, that is s cube, s square, s to the power of 1 and s to the power of 0. So this will be 1, 2, I hope you know, 2k, 4 minus k divided by 2, that is equal to, next 0. So this will be k into 0. Okay, so to find out the what is the value of k? For the system to be stable, the first column of the array must be positive. So k must be greater than 0, right? So k must be greater than 0. So I need to find out the another value of k, that is 4 minus k divided by 2 also must be greater than 0. So if I substitute this, if I equate this to the 0, then the k what I am going to get is equal to 4, right? K will be equal to 4. This is a K margin. Now, to find out the intersection of root locus with the imaginary axis, I need to consider the auxiliary equation, that is to the power of 2 term. Consider auxiliary equation. So this will be 2s square plus k is equal to 0. So what is s square? S square is equal to minus 2 when k is equal to 4, right? I am going to substitute k is equal to 4, and I found out that s square is equal to minus 2. Therefore s is equal to plus or minus I 1.4. So this is the intersection of root locus with the imaginary axis. Okay, next, what is step number 7? To find out the angle of departure. Why it is angle of departure? We have a complex pole, right? So we have a complex pole, so therefore, so we need to find out the angle of departure. So what is the formula to find out the angle of departure? Phi d is equal to 180 degree minus summation of poles minus summation of zeros. Okay, so now let us draw the pole 0 plot. What is the pole 0 plot that we have? Okay, so we have, what are the roots? We have s is equal to, so s is equal to 0, that is 0 is there, and minus 1 plus I, and another one is minus 1 minus I. So now I need to find out the angle of departure for this and also for this. So first let us find out the angle of departure for minus 1 plus I. Okay, so apart from this, so now I need to find out the phi p, that is phi p. So apart from this pole, we have another two poles. I am going to draw the line from this pole to this and this pole to this. Okay, so now I need to find out this one. This is a phi p1 and this one is phi p2. Okay, so therefore summation of phi p is equal to phi p1 plus phi p2. Okay, so this is minus 1 plus I. So from here to here, that is x, it is 1, y is also 1. So therefore phi p1 is equal to, what is phi p1? That is equal to 180 minus this angle. Okay, so this angle I can find out with the help of tan inverse of y by x. What is y? 1. What is x? It is 1. Correct? So therefore, so phi p1 is equal to 180 minus tan inverse of 1 by 1, that is equal to 45 degree. So I am going to get 135 degree. So from this phi p1 is equal to how much? 135 degree. Now from this, what is the phi p2? Phi p2 is equal to 90 degree. Correct? So therefore angle of departure, that is phi d, is equal to 180 minus, what is summation of phi p that we got? That is 135 plus 90 degree. Correct? Minus summation of phi 0 is 0. Why it is 0? So we don't have any zeros, right? So that's why. So there is no zeros, hence there is 0. So therefore phi d, that is equal to minus 45 degree. Okay, if phi d, that is what is the, we are trying to find out the angle of departure at minus 1 plus I. So therefore what is the angle of departure for minus 1 minus I? That is phi d dash, that is equal to 45 degree. That is the conjugate, right? So that's why phi d is equal to minus 45. Phi d dash or d1 is equal to 45 degree. Okay, so next what? So we are going to draw the root locus for this. Okay, let us draw the root locus for this. So my graph sheet is ready. I have taken the scale of 1.5 centimeter for each unit in the x-axis as well as y-axis. First I need to mark the roots. Let me mark the roots. So what are the roots that we have? So s is equal to 0, that is the pole. Then another root we have s is equal to -1 plus I, and here I have -1 minus I. Okay, these are the two roots that I have. Then what else we need to mark? So we have to mark the centroid minus 0.66. So centroid somewhere here. Okay, centroid is how much? Minus 0.66. Okay, from the centroid we need to mark what? Asymptotes, angle of asymptotes. For that I am going to take the protractor. So first asymptote is equal to theta 0, that is equal to 60 degree. I am going to mark 60 degree, that is theta. Then theta 1 is equal to 180 degree. This is a theta 0, that is equal to 60 degree. And so here also theta 2 is equal to how much? 300 degree. The theta 2 is equal to 300 degree. Now I am going to draw the lines like this. Okay. So this theta 1 is equal to 180 degree. So what else? Next we have to find out the breakaway points. So in this problem, do you have breakaway points? So after checking the angle condition, we found out that there is no breakaway points at all. Okay, then that is over. Next we need to find out the intersection of root locus with the imaginary axis. So it is intersecting at how much? 1.4, right? Plus 1.4 I and minus 1.4 I. So somewhere here. So this is the intersection of root locus with the imaginary axis, that is I 1.4 here, somewhere here. Okay, so minus I 1.4. okay now. So next what? So we have to mark the angle of departure. So from here, so I'm just going to take the reference line like this. Here also I'm going to take the reference line. So what they are saying, angle of departure phi d is equal to minus 45 degree. Minus 45 means what? It has to be downwards. From here downwards I am going to mark minus 45. So just I am going to draw a line like this at an angle of minus 45. So for this point it is plus 45. So above the reference line. So plus 45. So like this I am going to draw the line. This is the angle of departure. Okay. So right. So at this value, the intersection of root locus, so the image k value is equal to how much? 4. Here also k is equal to 4. Okay. So now after marking everything, so now we need to draw the root locus, right? So as we know, the branches are going to start from the poles. So when the k values gradually increase from 0, so the roots are going to start from the branches. That is, one root is going to start from here. It will follow until some point. So it is going to follow the angle of departure. Okay. So from the s is equal to 0, so we don't have anything. So it has to follow the theta 1 asymptote. Okay, this is going to follow and this end up to infinity. And from these two roots, So it is going to follow and it is going to intersect at the imaginary axis at minus 1.44 and also plus 1.4 I. After this it is going to follow the asymptote like this. Another branch is going to follow the asymptote like this, right? So 3 branches are there. So first branch is going to start from s is equal to 0, minus 1 plus I and minus 1 minus I. So s is equal to 0 branch, that is going to follow the theta 1, that's the asymptote 180 degree, and it is end at infinity. And here another branch is going to start from minus 1 plus I. It in the initial it is going to follow the angle of departure, that is equal to minus 45. Then it is going to follow the theta 0. So here minus 1 minus I, it is going to follow the angle of departure and it intersect at minus 1.4 when the value of k is equal to 4, and it's going to follow the asymptote, right? So this is what the root locus for this given problem. Now the very much important point to write down the comment on stability. What is comment on stability? What is the comment on stability? See here, so when will be the system will be stable? So after when k is equal to 4, the root locus is on the imaginary axis, that means k margin. So at k margin, that is equal to 4, the system is marginally stable. So this one is marginally stable. So therefore what is the stable region? So k must be greater than 0, right? It must be greater than 0 and it should be less than 4. This is the stable region. Why it is stable region? The root locus is lying to the left side of the S-plane. So in between the values of k, that is 0 and 4, the root locus is to the left side of the S-plane. So this is a stable region. So when k becomes more than 4, then it is going to enter to the right side of the S-plane, that is the unstable region. So this is the unstable region. So this is what the comment that you have to write at the end of the problem. I hope you understood. Thank you. Namaste.